This video is an introduction to PowerSource Insight. PowerSource Insight is an application program that allows you to manipulate your PowerSource database, which contains all the settings that you like to use for machining. So, what exactly is PowerSource? PowerSource is a technology that's embedded within Prospector that causes it to go out and query a database to ask about what I should do to fill in parameters when I'm creating a new program. And let's give you an example of that by starting in Prospector and creating a new 3D program. And you can see on the very first page here, stock allowance, that's been filled in. What just happened was Prospector went out, ran PowerSource and says, please go get me the stock allowance I should use for this particular job at this particular stage of machining. So we're doing rough machining. Our material type is P20. The configuration we're using is plastic injection mold. So it's reaching into the database saying, please give me the stock allowance for this situation. And here's what PowerSource returns back. So let's go ahead and walk through the wizard. We'll make a window around the part and say next. Same thing happened here. It took a trip to the database that says, here we are in rough machining. This is our first program. We're doing P20 tool steel and our configuration is plastic injection mold. What strategy should I use? And your within your database, it's saying, oh, Z-planar with clear is the most appropriate because we want to do maximum stock removal. So that's why it's chosen Z-planar with clear. We go ahead and say next, and it's automatically selected a tool. Now this is why it's so dynamic, because what Prospector's doing is feeding into PowerSource saying, here's the window, here's the size of the window, here's what's in the window in terms of the depth of the part, the amount of stock on the part, the minimum radius it sees within the window. Given all this information, it provides that to PowerSource, which then queries the database, which runs a set of rules to figure out what's the most appropriate tool given what I see here. And it's made a decision for us. It's picked this tool from our tooling database and plugged in the associated feeds and speeds that are appropriate for this material type. When we get to the parameters page, the same thing has happened. For this window, it's filled in start Z and end Z. And again, it's consulted with your PowerSource database saying, okay, here's what I see within the window. Tell me where I should start and where I should end. The step down and step over are coming from the tooling part of the PowerSource database saying this is the step down, this is the step over that's appropriate for the tool we chose. All the other program parameters are set the same way. What type of clearing do you wish to use? Everything comes from your PowerSource database for this particular program. Some of the settings are dynamic, like start Z and end Z, based on what we see at the moment within the window, and others can be somewhat static, like clearing. What's my preference for clearing? Okay, let's take a look at PowerSource Insight. We'll go to the program group for Prospector and go ahead and start up PowerSource Insight. Okay, first thing we call your attention to is the database itself has two mirror images. One is, and they're based on units, one is for inch and one is for metric. They're identical. The only difference is when we're working in a metric project, it's going to use the rules from the metric side. In an inch project from the inside. So if you're a metric only shop, you probably wouldn't care about the inside. So you don't even need to fill out anything or change anything on the inside. You want to focus on the metric side. So make sure you're in the right bin when you're creating your rules or altering your rules. If you're a mixed shop, don't forget you've got to do it on both sides. Sometimes you're in inch, sometimes you're in metric. You want to make sure you do both sides of the database. Okay. Over here in the tree, you'll see two nodes. Let's talk about application settings first. Application settings applies to all configurations, all materials, all machining strategies. So these application settings are global. In the property sheet here, you see the names of the properties and then the value. Value is essentially 4 different types. There's a string type, a numeric type, an enumerated type, and a Boolean type. An example of a string type would be this cache directory. So we would go, where does Prospector create his temporary files? So that's a path to a folder on your hard drive. So if we were to go in here and change this, like C:/temp, we need to remember to wrap a string value in double quotes, always in double quotes, and hit the return when you're done. Now notice that's turned it's turned red, and that means you've made a change for this particular setting from the default settings. If you ever need to go back to the default setting because you goofed something up or you forgot what it was or it's just not working right, you can always go in here, select it, backspace, and then hit a carriage return. That'll go retrieve the default setting and automatically fill it in. So don't worry about making a mistake or messing something up. You can always go back to your default. Some of these other settings, this is an example of a numeric setting, a floating point setting. Again, we can change this however we want, 0.005. Often, you will probably not even know what the heck is arc tolerance. That's where this guy is so helpful. It's called What's This? In the help menu, and the cursor changes to the little question mark there, and you just click on what the property is, and you'll get a little pop-up dialog there. They'll give you a quick summation of what is that. And there's lots and lots of settings. Nobody can be expected to remember them all in their head. So remember, What's This is your friend to find out really quick what's going on. So that's a numeric value. This is an example of a Boolean. Now, Boolean means yes, no, on, off, 1, 0. And this is saying, do we want to filter the surface data when we make a new project? Over here, you'll see a drop down for these. It makes it easier to enter it. Is say, if you want to say yes, yeah, let's go ahead and filter that. Just use the drop down to pick a new value. Sometimes you'll see this is an example of a conditional, and we won't talk about conditionals in this video, but linear interpolate rapids is a Boolean as well. So he'll have a drop down here if we wanted to say, just go ahead and say no to that. And again, you can see these guys turn red, saying we changed them. And to get back our default, backspace over it and hit enter. I'm going to restore these. Okay, so that's application settings. They're global to all projects that you're going to create in inch, regardless of anything else. Let's go up here to cutting strategy selection under configurations. In the first level we have here is the different material types that are defined. We're using the default database for Prospector, which has only 2 materials defined. P20 tool steel, very hard steel, and then mild steel for mold components because we're kind of mold centric. If we open P20, we'll see one configuration here called plastic injection mold. Okay, what's a configuration? A configuration can be anything you want it to be. It's a collection. It's a way of taking a collection of settings, rules, and saying this is for this particular application. So what we've done, we created one called plastic injection mold, which is just a generic set of rules that are apropos for machining a plastic injection mold from P20 steel. But it can be anything. You could make a configuration specific for your big roughing machine that you always use to rough jobs, and that would have rules and settings that are appropriate for just that machine and just for roughing. You could have it based on day shift, night shift. So maybe day shift has more aggressive settings for feed rates and cutting depths than perhaps the night shift does. It could be on per person, like Joe likes prefers these type of settings, and Al he likes to do zigzag. Joe likes to do spiral clearing. Those can be two different configurations. You can have as many configurations as you like. So we've just got the one plastic injection mold here, and we'll open that node. And we'll see three more underneath. There's feature-based machining and remachining, which we're not going to discuss in this video. That's an advanced video. But let's get into basic machining. We'll open that, and boy, doesn't this look familiar. Once again, here's the different stages of machining for a plastic injection mold. P20 is our material, and we're doing roughing. Let's open this guy up. So in the rough category, what do we got over here? You can see here's our stock allowance. So this is a numeric value, 0.075, but let's change it. Let's say 0.05. And again, he turns red because we just changed him. If we go back to Prospector, well, first of all, in Insight, let's go ahead and save our database because I just made that change. Go back to Prospector. Let's do a new 3D program. And you can see the stock allowance is now 0.05. Prospector automatically recognizes when you change your database, and he'll automatically update. So that lets you go ahead and change a setting, and then right away Alt-Tab to Prospector and go ahead and try out that new setting, make sure it works. So let's go back to Insight and put that back the way it was, 0.075. So for roughing, here's the settings at the top of this that apply to all programs, all different strategies. Here's what we want to do. This is when we chose a cutting strategy and walked through the wizard the first time. It says if I don't have a previous program, what should I use? Z-planar with clear. That's how it came up with the cutting strategy to use. Let's go ahead and dive into the 3D strategies themselves. So let's go ahead and open this node. Now these are all the different 3D strategies that are available in Prospector. So let's open up Z-planar with clear and look at that. I mean, it's all the possible parameters that can feed into creating a Z-planar with clear program. So this is a little daunting at first when you look at it, that you can see that we've programmed in by default some concepts that we won't talk about today, like expressions and rules and conditionals. For example, that's what we see with tolerance. We're saying we want to use 1/3 of the stock allowance for a tolerance provided it's no greater than 0.02 and no smaller than 0.001. Now that may be too cute by half for you, and you say, well, let's just always use a 0.0025 as our tolerance for a roughing. That's fine. You can change these any way you want to accommodate how you like to do machining. So as we go down here to, let's see here, what's a good one? Oh, clearing style, right. say you do zigzag clearing. You don't like spiral, outside in or inside out. That's no good. That you always zigzag. Go to your drop-down menu. Get this example of an enumerated type which has discrete settings, and choose zigzag clearing. Great. That way when you walk through the wizard and you get to the parameters page, zigzag will always be the way you like to clear. You can see here, looking at some of the settings, whether we want to machine floors, do we want to add levels at floors, another discrete setting. Maybe you say, don't do that. I want a fixed step down. Don't insert any extra levels. Don't forget, with the what's this, he's your friend, because a lot of these are a little curious, like what is fast feed rate? That's, if I use what's this, click on him. So that has to do with when the tool needs to retrace to get to the start point to descend to the next level. That's the feed rate to use. And he's using the cutting feed rate. But that may be too slow for us. And we can just say something like, instead of going that slow, let's go at 90 inches per minute. Here's tool setup, which has things like our station number, length compensation register, spindle speed. Now you can see it's set up to use whatever's associated with the tool that we chose. So whatever tool we chose with Z-Planar with Clear tool, go get his station number from the database and use that. Coolant. Here's an example of a conditional that's saying, if the previous program is there, whatever you use for coolant before, you're probably going to want to use the same setting. Otherwise, if there isn't a previous program, we don't want any coolant. Well, maybe that's no good for us. That we always like when we're roughing to use through the tool coolant. So again, hit the drop down. This is an example of an enumerated type. So choose through to set that up. Tool selection. The first decision we need to make is what type of tool do we want to use. So again, he's asking, this is another conditional. He's saying, if you got a previous program in the roughing group, use that tool type. Otherwise, if we haven't set anything, just use a bowl cutter. So if we open up bowl tools, you can see we've kind of programmed in a rule here that we found works well. That we say use 10% of the shortest side of the window that we're using. And you can see if you look out here, this is a little bit interesting. We've added a comment there just to let you know this is what we're doing here. Comments are introduced with a single quote. You'll always find them at the end. Like down here, when we're selecting the tool, we're saying we prefer a tool with a large step down. So these are the hints we've given PowerSource saying when you look in that tooling database, you're going to look in the rough category for P20 material, for Z-Planar with Clear, and here's some clues. This is my diameter I want, and we just put in 100 for a length because if there's more than one tool there, we would prefer to have the one that has a greater step down. So let's close him up and go look at finish. As you can see, when we get into the finish category, we're not leaving any stock anymore because we're doing finishing. So that's why these are broken out into different categories, because you're going to want to use different parameters based on the stage of machining that you're in. So when we go to lace cut, we may want to go ahead and use higher feed rates, spindle speeds, taking a lighter step down. When we're doing Z-Planar, there's quite a few differences we would make there. Certainly our tolerances would be a bit tighter as well. So you want to keep that into consideration when you're setting up your rules. Similarly, if you're going to use the mild steel, you've got to come in here. Here's the mold components, configuration, basic machining. It's laid out the same. Roughing. Usually, mold components is a lot of 2D machining, so you'd open up 2D strategies and say, okay, for pocketing, what makes sense for us in doing 2D machining when I'm pocketing? And you can see we've set up some default rules for pocketing here. So it's all here for you to work with. And now that you know how it's organized, it should be enough to get you started. Now, I'd recommend you work with our default database and how we've got it configured and get comfortable with making changes here, and make sure you go ahead and you test them out in Prospector that they're appropriate for what you're doing. Okay, so with what we've learned so far, let's take a look at how this can save you quite a bit of time when you're actually doing programming in Prospector. So we'll go back to Prospector, and we're going to make a finished program here. So I'm going to say new 3D program. And up comes our remaining stock model. So you can see on this area of the part, we've got some stair steps here. If we go into the top view and manipulate the remaining stock model, I'll just get two colors here. You can see the green in here, that we've got some stair steps. If we look at the stock model view, yeah, you can see that this is some stock left over from the previous programs that we need to knock down. So let's go back to the 3D view, and I'll make a rectangular window over this area. That's fine. And we look at in the window, you can see that the maximum amount of stock in that window is 0.163. Let's remember that. Let's walk through the wizard. He's going to pick lace cut. That's fine. Selected a tool for me automatically. That's nice. I don't need an assembly. And I want to go parallel to the x-axis, so I'm going to change the angle here to 0. And let me just increase this step over a bit, and then say go ahead and finish. Okay, there's my program. Let's go ahead and build it and take a look at what we got. Go into an isometric view and zoom in here a little bit, and there's my lace program to do the finishing. So let's go ahead and simulate this. I'm just going to step through here. Next, next. There's a rapid over from the home position. Now down in Z, and the lace program begins. So if we zoom in here, we can see clearly what happened. The red is rapid motion. The green is at plunge feed rate to go down into the stock before we start actually doing the lace cuts back and forth. So if I use my measure tool here, measure distance between 2 points, let's see how long this is. And it's 1/10 of an inch. So if you remember from the remaining stock model, we said that it was 0.163 was the maximum amount of stock there. So as we came down to the part here at rapid, we actually could have rapid right into the stock if perhaps that was 0.163. So we'd really like this plunge feed rate, this distance here, to be greater than that. So where's that at? As we walk through the wizard creating this program, we're doing update right now, but we would have seen the same pages. There's my tool, there's my parameters. Well, I don't see anything here to control that plunge distance before we begin the lace cut. So where is that? It's all the way back here on the finish page. And if you notice over here it says show advanced settings. That's set to on. When we turn that off, these are all the settings we would have seen as we went through the wizard itself. When we turn it on, these are all the settings that apply to that lace program. So if we look in here, we're going to see the things we saw on the wizard and also what's not on the wizard. So pay careful attention to what you don't see. So what are we looking for? The setting that allows us to control how close we get to the part data before we actually switch to plunge feed rate is called feed distance approach. And it's currently set to a hard coded just 0.1 inch. So that means for every lace cut, I would have to come to this page and make this alteration. You know, if 0.1, I don't like that. That's too close. I could hit stock. So I can just change this to 1/4 inch and say, oh, and then say finish. Let's go ahead and rebuild this. And there's our plunge. And if we measure him, it's 1/4 inch. Now that's a pain in the neck if you have to go to the finish page each time and make that change. So the better strategy is, let's go into our PowerSource database. Let's go to the finish category here. We'll go to 3D strategies, lace, and there's our feed distance approach. So what I can do is just change this once, and we'll just change it to 1/2 inch. Let's just be ultra conservative here. We'll go ahead and save this guy. And then go back over into Prospector. Now, changing a setting like that is not going to change any existing programs. Any new programs will pick up those new settings. So let's put him away, and we'll do the same thing again. We'll go ahead and recreate that. Go to top view here, and I'll drag out a rectangular window here. That's fine. We want lace. Just chosen my tool again. We want to go at 0 degrees. Step over, we'll just say 0.1, and then say finish. Build it. Load it up. Go to an isometric view here, zoom in, and there's our feed distance approach. Let's go ahead and measure that. And he's 1/2 inch. So any lace program I make in the future, I'm not going to have to visit that finish page and change it. And just to give you a little taste of what you can do with Prospector and PowerSource Insight, and we'll do a deep dive into expressions and sources and how to write rules in a future video. But if I wanted to, what I could do is go down here and actually use a variable. So instead of having a fixed value here like 0.5, what I could put in here instead, excuse me, is the maximum stock in the window. So remember that when we first went through, it said 0.163. It was the maximum stock in the window. So it'd make a lot of sense if my feed distance approach was that maximum amount of stock it saw in the window. That way I'm sure that I'm not going to wrap it in the stock. And then just to be on the safe side here, we could go ahead and say, let's say add 1/10 inch to that. So we'll make sure that we wrap it well short of the stock and then plunge feed rate into the stock. So let's save that. Go back to Prospector, put that away. We're doing the first 3D program in the finish category again. Go to the top, and let's do a rectangular window here. And you look at the stock, it's 0.149. Let's keep that in mind. Tool. Let's go at an angle of 0. Let's do a step over a 0.1. Say finish, cancel, and build that. Okay, let's take a look again. Go into isometric view. Let's zoom in here. And there's my feed distance approach at plunge feed rate. Let's measure this guy. Oops, didn't want to do that. And you can see it's kind of an oddball value, but it's 0.1465 was our maximum stock, and we added 1/10 of an inch to that, and there we have it. So I'm positive I'll never wrap it into the stock, because it's always going to look at the maximum stock in the window and then add 1/10 of an inch to that. So that gives you an idea of the power that you have over all these different variables that comprise the parameters for the program. And we'll do a deep dive into what the rules are and expressions in a future video, and then you can really start to take advantage of it. So for now, just work with our default databases and go ahead and change whatever settings you like, so that you're getting the style of programs that you like. And then in a later series, we'll talk about how to set up your own database and how to customize that in terms of materials, feeds and speeds for materials, and rules for how you like the program. So if you have any questions, you know how to get hold of us. Our contact information is on our websites, and we'd love to hear from you. Any questions, we're more than happy to answer. Thank you very much, and we'll see you in a future video.